Humans always seek new frontiers, whether in deserts, islands, or mountains. Wherever there's room to grow, humans venture forth. It's no wonder that we're gearing up to explore Mars and establish humanity's first permanent settlement beyond Earth. We may even transform another planet into a new home for humanity. However, before we can delve into the promising aspects of the future, we must first accomplish the second phase of colonization, establishing a semi-permanent outpost to lay the groundwork for a more extensive human presence. Yet the task ahead will be daunting. Mars, despite its apparent familiarity with polar ice caps, vast valleys, liquid water beneath its surface, and a day just slightly longer than Earth's, presents extreme challenges even for a species as exploratory as ours. While Mars may seem like the perfect destination at first glance, the reality is far from ideal. Mars is a frigid, radioactive desert where the soil is toxic and sustaining life through breathing is impossible. Mars is truly dreadful. It's highly unlikely you desire to journey there. Pioneers tasked with the challenging work on Mars will face exceedingly stressful lives, grappling with unprecedented and formidable obstacles. However, there are numerous individuals eager to undertake such tasks, and we possess the technology to facilitate their efforts. In this video, we'll presume earlier expeditions to Mars have scouted potential outpost locations, stored resources and equipment, and established a moon base to facilitate Mars missions. Our outpost faces a significant challenge due to Mars' limited energy resources. Solar power, essential for operations, is only 40% as efficient as on Earth due to Mars's greater distance from the Sun. However, even this diminished sunlight is frequently blocked for days by immense dust storms on Mars. Solar power alone might not suffice. Wind power and geothermal energy, however, are impractical alternatives due to the sparse atmosphere and Mars's excessively cold interior. Initially, nuclear technology might be the sole option. However, Mars lacks easily accessible radioactive elements, so the nuclear fuel must be transported from Earth along with the reactor. If we manage to set it up, the nuclear power source could sustain our small outpost for the initial years. However, having ample energy won't be of much use if we cannot breathe. The atmosphere on Mars is merely 1% as dense as Earth's, primarily composed of carbon dioxide. Now, habitats must be pressurized and filled with an artificial atmosphere composed of nitrogen and oxygen, which brings additional challenges. To manage the stress of significant pressure differences between the interior and exterior, habitats will feature rounded and smooth shapes, avoiding corners and flat walls which are weak points. The airlocks must be airtight and operational flawlessly every time. Due to the lack of an extensive magnetosphere or a dense atmosphere, half of all radiation from space reaches the ground. Yet a person on Mars would face 50 times the radiation they would on Earth. 3 years on Mars exceeds the radiation limits set for NASA astronauts in their entire careers. To mitigate the increased risk of cancer, we could shield our habitats with a thick layer of frozen carbon dioxide, which can be harvested directly from the Martian atmosphere. Adding a meter of dirt on top of the dry ice would provide additional protection. However, this would result in very few, if any, windows. Internally, living areas will resemble windowless tunnels, while externally, they will resemble burial mounds. Despite these measures, they cannot completely block radiation, but can reduce it enough for prolonged survival. However, these measures won't shield those who venture outside. Hence, remote-controlled robots will handle routine surface work, ensuring the safety of our crew inside. Remaining indoors is wise for another reason. Mars dust. It's finer than Earth's dust, posing a risk of infiltrating machinery gears or electronics. Additionally, due to its dryness, Mars dust becomes electrostatically charged, adhering to everything it touches, including spacesuits. Carrying large amounts of Mars dust into our habitat and the lungs of our crew will be unavoidable. Constant exposure to the very toxic perchlorate salts in Mars's soil could be deadly. This issue can still be overcome. For instance, spacesuits could be designed so that they never fully enter the base but remain attached to the outside of the habitats. All right, now that we've securely isolated humans in terms of energy and air, safeguarding them from cancer risks, our next task is to ensure they're adequately fed. Water is readily available if settlements are positioned near the Martian poles, where thick layers of ice can be found. Growing food presents a unique challenge. Mars's soils are alkaline and lack the essential nitrogen compounds that plants need to thrive. Before we can cultivate crops, we need to purify the soil, a task that's both challenging and costly. After purifying the soil, we can enrich it with recycled biological waste for fertilization. This process will be time-consuming and energy-intensive. Alternatively, we could explore aquaponics, a method that combines fish and plant cultivation, offering astronauts a diverse and flavorful diet. This will serve as a crucial psychological boost for our hard-working crew. However, none of these solutions address a fundamental issue. Mars possesses only 38% of Earth's surface gravity, potentially leading to muscle atrophy, bone deterioration, and cardiovascular issues. For now, our crew must cope with low gravity and maintain regular exercise routines to mitigate the effects. Although rotating living spaces may offer a solution in the future, the current crew will likely need to rotate every few years, enduring confinement in cramped, windowless quarters. Engaging in repetitive routines day in and day out with minimal contact from the outside world, the crew faces a monotonous existence, compounded by numerous worries and uncertainties. Similar to Antarctic scientists or submarine staff, the crew will undergo rigorous psychological evaluations to ensure they possess the mental resilience necessary to endure this lifestyle for several years. Creating the initial infrastructure on Mars will be an arduous task that only a highly determined and skilled group of individuals can accomplish. Fortunately, Earth possesses an abundance of such individuals. And there you have it. A modest Mars base poised to endure for several decades, provided it receives a steady stream of resources, components, nuclear fuel, and personnel from Earth. Regrettably, Mars and Earth are separated by vast distances spanning millions of kilometers, with orbital cycles permitting a narrow travel opportunity only once every 2 years. In the event of an emergency in the colony, Earth would be unable to provide assistance until the subsequent travel window becomes available. The prospect of helpers arriving on a planet filled with corpses is grim. Settling Mars represents the most formidable challenge humanity has encountered. Establishing the necessary infrastructure will entail gruesome and demanding work. Despite the daunting obstacles, we humans are known for our stubbornness and love for extreme challenges. If we persevere through Phase 2 of colonization, the realm of possibilities expands exponentially. Imagine cities lighting up the dark Martian night, serving as hubs for interplanetary travel and becoming the foundation for industries venturing into orbit, all contributing to the realization of a genuine multi-planetary future. Journeying to Mars is undeniably difficult, yet the rewards make it worthwhile. If we're fortunate, we may witness this remarkable endeavor unfold and offer our support to those brave individuals tackling these challenges for the betterment of humanity.